At 5:30 a.m. on February 10, 1942, the first completed M4 Sherman tank rolled off a production line in Warren, Michigan. It weighed 33 tons. Its armor could stop a standard anti-tank round at close range. Its 75mm gun could destroy almost any German tank then operating in North Africa. A crew of 5 men could start its engine, engage its tracks, and move it into combat within 90 seconds. None of the 22,000 workers who built it had ever worked in a tank factory before that year. Most of them had never seen a military vehicle up close. The plant where they built it had been a wheat field 18 months earlier. This is the story of how the United States turned an empty patch of Michigan farmland into the most productive tank factory on Earth, how ordinary men and women mastered processes that military engineers said would take a decade, and how the Sherman tank, produced in numbers that German commanders refused to believe, helped end the Second World War. The problem nobody wanted to admit. In the spring of 1940, the United States Army had 464 tanks. Germany had more than 3,000. The Soviet Union had over 20,000. Britain was producing new armor at a pace that still left its forces outnumbered on every front. American military planners knew the numbers. They also knew something worse: the United States had no facility capable of producing tanks at industrial scale. There were small foundries, custom machine shops, specialized armament plants. There was nothing resembling a mass production tank factory. The Army's requirements were staggering. War planners estimated that any serious ground campaign in Europe would require at least 40,000 tanks in the first year alone. The existing industrial base could produce perhaps 1,000. The gap between requirement and capacity was not a manufacturing problem. It was a civilizational one. The United States needed to build not just tanks, but the entire infrastructure capable of making them: the factories, the supply chains, the trained labor force, and it needed to do all of this simultaneously, in the middle of a global war, faster than any industrial mobilization in history. The Army Ordnance Department surveyed every viable option. Existing weapons manufacturers lacked the floor space. Shipyards had the scale but not the precision metalwork. The locomotive industry had the heavy equipment but not the volume production experience. Then someone looked at Detroit. The automobile men. In August 1940, Army Ordnance approached K.T. Keller, president of Chrysler Corporation. The meeting lasted 3 hours. Keller brought his chief engineers. The Army brought blueprints for the M3 medium tank, a vehicle so new that the design was still being revised. The Army wanted Chrysler to build a factory, hire a workforce, and begin producing tanks, a product the company had never made, in a facility that did not yet exist, to a specification that was still changing. Keller asked how many tanks the Army needed. The answer was 1,000 per month at peak production. Keller looked at the blueprints. He looked at his engineers. He said Chrysler would do it. The automobile industry's advantage was not experience with tanks. It had none. Its advantage was something more fundamental: it had spent 40 years perfecting the science of high-volume precision manufacturing. Every car rolling out of a Detroit assembly line in 1940 contained over 15,000 individual parts, each machined to tolerances measured in thousandths of an inch, assembled by workers whose motions had been timed, studied, and optimized to eliminate every unnecessary second. The principles that produced a Dodge sedan could, with modification, produce an M4 Sherman. The scale was different. The product was different. The logic was identical. Chrysler engineers spent 6 weeks studying the tank blueprints. Their first conclusion was that the M3's design made mass production nearly impossible. The hull required 108 separate machining operations. The turret ring needed tolerances that existing military foundries could barely maintain. The transmission involved 17 precision gears that no current American machine tool could cut at industrial speed. The Army had designed a tank. Chrysler needed to redesign the process of making one. Building the arsenal. The site chosen for the Detroit Tank Arsenal was a 113-acre parcel in Warren Township, 12 miles north of Detroit. In September 1940, the land contained 2 farmhouses, a gravel road, and winter wheat. By March 1942, it contained the largest single-building manufacturing facility in the world. Construction began in November 1940. Chrysler brought in Albert Kahn, the industrial architect who had already designed the Ford River Rouge plant and dozens of other American factories. Kahn had a rule: the building followed the production line, not the other way around. Before a single foundation was poured, Chrysler engineers mapped every step of the manufacturing process on paper. They calculated how many workers each station needed. They determined how raw materials would enter, how components would flow, how finished tanks would exit. The building then grew around this plan sequence like a shell around its contents. The main production building stretched 500 feet wide and 1,350 feet long. Its roof covered 18 acres under a single continuous span. Workers inside it could not see from one end to the other. Steel arrived by rail through loading docks on the north end. Finished tanks departed through exit gates on the south end. Between entry and exit, every component of the M4 Sherman passed through 218 distinct manufacturing and assembly stations. The distance a tank traveled from raw steel to completion was exactly 2,100 feet. At peak production, a tank completed that journey in approximately 28 hours. The production line itself was a Chrysler invention. No previous tank factory had used true assembly line methods. The British built tanks in fixed bays, where workers came to the vehicle. Chrysler moved the vehicle to the workers. The tank hull traveled on a continuous steel conveyor, stopping at each station for exactly the time that station required. If Station 47 turret ring installation took 11 minutes at full efficiency, then the conveyor moved the entire line forward every 11 minutes. Every station in the building worked to that rhythm. The entire factory breathed like a single machine. The workers. The factory opened its hiring office on January 15, 1942. Within 2 weeks, 8,000 people had applied. Chrysler's recruiters processed applications around the clock. The qualification requirement was simple: able-bodied, willing to work, able to follow written instructions. Prior manufacturing experience was useful but not required. Chrysler would teach the rest. The training program that Chrysler developed at the Arsenal became a model for the entire American war industry. New workers reported to a 6-week classroom and floor program. The first 2 weeks covered basic safety and factory orientation. Weeks 3 and 4 involved supervised practice on the specific machines or assembly tasks the worker would perform. Weeks 5 and 6 placed the worker on the actual production line alongside an experienced partner. By the end of week 6, most workers could perform their assigned operation at or near full production speed. Former auto workers formed the backbone of the early labor force, but they were never the majority. Among the Arsenal's eventual 22,000 employees were former schoolteachers who became precision instrument operators, former waitresses who became overhead crane drivers, former coal miners from Kentucky who became armor plate welders, former farmers from rural Michigan who became gear machinists. The factory absorbed people from everywhere and trained them to a common standard. Women entered the Arsenal workforce in significant numbers beginning in the spring of 1942, when male workers began departing for military service. By 1944, women held nearly 35% of production positions. They operated milling machines, ran inspection stations, performed hydraulic system assembly, and worked as lead hands supervising mixed-gender teams. Chrysler's management initially resisted the integration, citing concerns about the physical demands of tank work. The concerns proved groundless. Female production workers at the Arsenal consistently matched male productivity benchmarks. Several exceeded them. Black workers arrived at the Arsenal in larger numbers than at most comparable facilities, though not without friction. The United Auto Workers had a non-discrimination policy, and Chrysler, under pressure from government war contracts that required equal employment provisions, hired black workers into production roles rather than limiting them to maintenance and janitorial positions as many factories still did. By 1943, black employees made up roughly 12% of the Arsenal workforce. They operated production machinery, performed skilled welding, and in some cases held supervisory positions. The factory floor was not free of racial tension. But the production line imposed its own equality: every worker's output mattered, regardless of who was producing it. Inside Plant 1. The noise inside the arsenal was constant and total. Workers wore ear protection, dense rubber plugs that muted the surrounding roar to a dull, vibrating pressure. Communication on the floor happened through hand signals, written cards, or shouting directly into another person's ear. Veterans of the factory floor developed a fluency in gesture that functioned as its own language. A raised fist meant stop the line. 2 fingers pointed downward meant slow the conveyor. A circular motion overhead meant emergency, everyone steps back. The armor plate section occupied the northwest corner of the main building. Steel arrived in plates measuring up to 4 inches thick, each weighing several tons. Overhead cranes, operated almost exclusively by women after 1943, lifted the plates from railcars and positioned them on cutting tables with tolerances measured in fractions of an inch. Plasma cutters shaped the plates to whole dimensions. Hydraulic presses formed them to the curved geometries the M4's angled armor required. The bending of armor plate, which required applying thousands of pounds of force to metal that resisted deformation, was among the most physically demanding operations in the factory. It was also one of the most precise. A hull plate bent 2 degrees off specification could not be corrected. It had to be scrapped. Welding stations lined the center of the production floor in 2 parallel rows. At peak production, 340 welders worked simultaneously within the main building. The welding of an M4 hull required over 800 individual weld passes. Each pass had to meet a specified penetration depth, bead width, and visual appearance. Welders who failed inspection standards 3 times in succession were removed from production work and returned to training. The quality control standard was not perfectionism. It was a military necessity. A hull weld that failed in combat could kill 5 men. Summer inside the plant was brutal. The corrugated steel roof collected heat from the Michigan sun and held it. Temperatures on the production floor routinely exceeded 105 degrees Fahrenheit in July and August. Workers at welding stations operated in temperatures 10 to 20 degrees higher than the ambient floor temperature. Chrysler installed ventilation fans that moved enormous volumes of air without cooling it appreciably. Workers drank water by the quart and still lost weight through sweat. Heat casualties: workers who collapsed from exhaustion or dehydration averaged 4 to 6 per shift during summer peaks. The line never stopped. Supervisors pulled the affected worker, replaced them with a floor reserve, and the conveyor kept moving. The tank. The M4 Sherman was not the best tank of the Second World War. Military historians have debated this for 80 years, and the debate always arrives at the same conclusion: in a direct technical comparison, armor thickness, gun penetration, mechanical reliability, the German Tiger I was superior. The Sherman's armor was thinner. Its gun was initially less powerful. Its high profile made it easier to target. German tank crews called it the Tommy Cooker. American crews called it the Ronson, after the cigarette lighter that always lit on the first strike. But the Sherman was not designed to be the best tank in any individual engagement. It was designed to be available in overwhelming numbers at every point of need across every theater of a global war. And in that objective, the objective that actually determined the war's outcome, it succeeded completely. Germany produced 1,347 Tiger I tanks across the entire war. The Detroit tank arsenal alone produced more than 22,000 Shermans. Combined with output from Fisher Body, Ford, Lima Locomotive, Pressed Steel Car, and Pacific Car and Foundry, total Sherman production reached 49,234 vehicles by the war's end. The strategic logic was articulated by General Omar Bradley after the war: in battle, it wasn't 1 tank against 1 tank. It was 5 against 1. Production was the weapon. A Tiger could destroy 3 Shermans in an open engagement. It couldn't destroy 30. American commanders understood this arithmetic and used it. Soviet commanders understood it too. The industrial capacity behind the Sherman was not a compensation for the tank's weaknesses. It was the strategy. The numbers. The production statistics from the Detroit tank arsenal remain difficult to absorb even at a distance of 80 years. The facility consumed 400 tons of steel per day at peak operation. Its electrical demand exceeded that of the entire city of Warren. It used more cutting tools per month than the whole of the American automotive industry had used in its first decade of existence. Its two-land die shop, operating 24 hours a day, produced the specialized jigs, fixtures, and gauges that kept the production line in precise tolerance across 218 assembly stations. By April 1942, just 14 months after ground was broken, the arsenal was producing 100 tanks per month. By October of that year, monthly output had climbed to 400. By mid-1943, production reached its peak of over 600 vehicles per month. The factory operated 3 shifts of approximately 7,000 workers each. Shift changes occurred at 6 a.m., 2 p.m., and 10 p.m. During the shift change period, which lasted roughly 20 minutes, over 7,000 workers exited the facility through the south and east gates while another 7,000 entered through the north and west gates. Local police estimated that the twice-daily flow of arsenal workers created the largest sustained pedestrian movement in the state of Michigan outside of a major sporting event. Engines came from Ford's River Rouge facility, 22 miles south. Transmissions arrived from a dedicated Chrysler plant in Detroit. Guns were shipped from the Rock Island Arsenal in Illinois. Radios came from RCA in New Jersey. Optical sights arrived from Bosch and Lohm in Rochester, New York. By the time a Sherman tank reached the end of the arsenal's production line, it contained components from manufacturers in 19 different states, assembled by workers who had never met each other, machined to specifications that allowed them to fit together with the precision of a pocket watch. The tanks go to war. On the morning of June 6, 1944, 1,500 Sherman tanks participated in the Normandy landings and the operations that followed in the first week. They came ashore on landing craft built in Louisiana, through surf that killed hundreds of men before the beach was reached, and drove inland against German defenses that had been designed precisely to stop them. Many were destroyed. Many more kept moving. The German defenders at Normandy had a total of 200 operational tanks within range of the landing beaches on D-Day morning. The Allies landed 3 times that number in the first 48 hours. Arsenal workers learned about Normandy from radio broadcasts and newspapers during their shifts. Supervisors who heard the news passed it along at station to station. Workers who understood what the landing crafts and tanks meant, whose production they were part of, whose lives depended on the quality of their welds and the precision of their machine work, responded in different ways. Some wept. Some felt a surge of something they could not name. Most simply kept working. There were more tanks to build. There were more landings coming. The Pacific Theater, Leyte Gulf, Iwo Jima, Okinawa would require everything the arsenal could produce and more. The Sherman tank served in every major American ground operation of the war. It fought in North Africa against Rommel's forces. It drove across France after the Normandy breakout. It crossed the Rhine and entered Germany. In the Pacific, modified versions with close support guns cleared Japanese fortifications on island after island. Soviet forces received over 4,000 Shermans through the Lend-Lease program and used them to devastating effect on the Eastern Front, where their mechanical reliability, far superior to any Soviet tank then in production, made them especially valued. Every one of those vehicles traced its design lineage through the Detroit tank arsenal. Many were built there. After the war. In August 1945, Japan announced its surrender. The Detroit tank arsenal received notification of contract reduction within 2 weeks. Production slowed. Overtime was cancelled. Workers who had been pulling double shifts for 3 years began going home at regular hours, and then began receiving layoff notices. By December, the workforce had been reduced to 4,000. By mid-1946, it stood at 800. The assembly lines that had run continuously, 24 hours a day, for 4 years went silent one section at a time. The last wartime Sherman rolled off the line on October 22, 1945. The workers scattered. Some returned to the auto industry, where the skills they had acquired, precision machining, overhead crane operation, quality control inspection, made them highly employable in the post-war manufacturing boom. Others left manufacturing entirely, taking advantage of the GI Bill and its equivalents to pursue education or start businesses. Some simply went home to the farms and small towns they had left when the arsenal opened, carrying with them knowledge of industrial processes that had not existed in their communities before the war. The arsenal itself survived. Unlike many wartime facilities that were demolished or converted beyond recognition, the main building in Warren, Michigan still stands. It has operated continuously since the war's end, producing M48 Pattons during Korea, M60s during the Cold War, M1 Abrams tanks during the Gulf War and beyond. The Detroit Arsenal is still an active military production facility today, making it one of the longest continuously operating tank manufacturing sites in the world. The building that Albert Kahn designed for Chrysler in 1940 still shelters production lines. The ghosts of 22,000 wartime workers walk its floors. What they built. General Dwight Eisenhower, reflecting on the Allied victory in Europe, identified three factors that made it possible: the Soviet Army's sacrifice on the Eastern Front, the logistical genius of the Allied supply system, and American industrial production. He did not list specific battles. He did not credit the tactical brilliance of individual commanders, though there was plenty of it. He credited production. He credited the factories. The 22,000 workers of the Detroit Tank Arsenal received no medals for their contribution. There was no parade in Warren, Michigan when the war ended. No monument was erected in the parking lot of the facility where they had spent 4 years of their lives working in heat that blistered their hands and noise that damaged their hearing. The victory celebrations in Times Square and on the streets of London and Paris honored the soldiers who had fought, as they should. The workers who had armed them returned to ordinary life without ceremony. But the record is precise and it does not fade. The Detroit Tank Arsenal produced 22,234 M4 Sherman tanks between 1942 and 1945. Those tanks fought on 5 continents. They destroyed enemy armor, broke through defensive lines, and carried Allied forces from the beaches of North Africa to the gates of Berlin. They were built by former waitresses and schoolteachers and farmers and coal miners who had never seen the inside of a tank factory before the war demanded that they learn. They were built on land that was a wheat field in 1940. They were built to a standard of precision that military engineers had believed would require a decade to achieve, and they were built in 18 months. That is the story the history books miss when they focus only on the battles. Wars are won in factories as much as on fields. They are won by the woman running an overhead crane at 3 o'clock in the morning, by the machinist who discovers that a worn cutting tool is drifting a gear tooth out of tolerance and stops the line to fix it before a transmission fails in combat, by the supervisor who walks the floor every hour checking that every station is running to spec. They are won by the accumulation of ordinary precision, repeated across millions of operations, by people who understood that their work was the difference between a soldier who survived and one who did not. The tanks are mostly gone now. A few survive in museums, one at the Patton Museum of Cavalry and Armor at Fort Knox, several at the National Armor and Cavalry Museum at Fort Benning, a handful in private collections, and dozens in European memorial parks, standing guard at the sites where their predecessors fought. The workers who built them are gone too, the last of them passing in the 1990s and early 2000s, their stories largely untold in the standard histories of the war. But their contribution is embedded in history in a way that cannot be erased. Every account of the Allied breakout in Normandy acknowledges the armor that made it possible. Every analysis of why Germany lost notes the production disparity that overwhelmed its tactical advantages. Every history of the Second World War, written from any national perspective, eventually arrives at the same conclusion: the Allied industrial base centered in Detroit, drawing from every corner of the American continent, produced materials in quantities that no opposing power could match or endure. That industrial base did not appear from nowhere. It was built by K.T. Keller and his engineers working through the winter of 1940 to solve manufacturing problems that had never been solved before. It was built by Albert Kahn designing a building around a production line that didn't yet exist. It was built by 22,000 men and women who reported for their shifts in the dark and the heat and the cold, who bent steel and laid welds and ran machines and drove cranes and inspected tolerances, shift after shift, year after year, until the war was over. The assembly lines in Warren are still running. The building still stands. The work continues in a different form, for different machines, for a different era. But the foundation, the knowledge that ordinary people, given extraordinary purpose and the tools to achieve it, can build things that change the course of history, that foundation was laid between 1941 and 1945, in a factory built on a Michigan wheat field, by workers who understood that every tank they finished was a life they might be saving. 25,000 tanks. 22,000 workers. 4 years. That is the legacy of the Detroit tank arsenal. Not the battles it armed. Not the generals who directed those battles. The workers. The production. The relentless, precise, unglamorous work of building history one tank at a time.